AI tokens got 98% cheaper in 3 years. So why did the average company's AI bill explode from $1.2 million to $7 million? Using Stanford's 2025 AI Index, the left axis shows inference costs plummeting. In 2022, a million tokens cost $20. Today, 40 cents. Managers assumed bills would collapse. Instead, average enterprise AI budgets violently expanded from $1.2 to $7 million. To understand the disconnect, look at how entry-level AI subscriptions operate. They function like early, subsidized Uber rides. A $20 monthly fee is artificially low, designed to build user habits and capture distribution. Underneath those flat rates, major providers are quietly separating out the expensive behaviors. Functions like web search, data residency compliance, and prompt caching are being carved out of base-listed API prices and shifted into metered add-ons. Relying on the assumption of an ever-cheaper software infrastructure is a dangerous operational illusion when applied to artificial intelligence. A cheaper token does not automatically equal a cheaper product. The discrepancy widens when we factor in thinking token variance. This acts as a hidden cost multiplier inside frontier models. A 2026 research paper analyzed 8 frontier reasoning models across multiple tasks. They found that in over 20% of comparisons, the model with the cheaper listed price actually generated a higher total cost. At the extreme end of this variance, identical tasks cost up to 28 times more to execute. The difference was entirely driven by the volume of internal reasoning the model performed before generating an output. Standard models act like calculators, answering queries with predictable, linear compute. Premium reasoning models function economically like highly paid consultants. The expensive component is the internal cognitive work, not the final printed answer. For complex work, listed token prices are irrelevant. The true financial risk is hiding in the invisible, variable internal thinking of the system. This exact dynamic was mapped out over a century ago. The modern AI cost explosion follows the logic of a 19th century economic theory known as the Jevons Paradox. In 1865, the English economist William Stanley Jevons published a study analyzing British coal consumption in the wake of significant technological advancements. He observed that engineering a more efficient steam engine did not decrease the nation's coal use. Instead, it multiplied the consumption of coal. Jevons concluded that as a resource becomes cheaper and more efficient to use, the total market of viable use cases expands. The resulting surge in demand overtakes the savings from efficiency, skyrocketing total consumption. This maps directly to AI economics. Drastically cheaper tokens make highly complex, computationally greedy behaviors financially viable for the first time. Cheaper raw compute is not a cost-saving measure. It is the catalyst driving exponential budget growth. We are seeing a split in the market, the divide between cheap AI answers and expensive AI labor. A standard chatbot interaction is a simple conversation. It operates as an isolated, one-and-done token exchange. AI labor relies on an agentic workflow loop. While the user sees one task, the agent is reading massive context repositories and establishing state. Next, it queries tools and executes code, each step a distinct model call. If the code fails, the agent analyzes the mistake and autonomously triggers a retry loop, running the entire sequence again. What looks like one simple user request translates economically into a bundle of hundreds of invisible model calls, tool uses, and compute cycles. The billing unit of enterprise AI has moved to the autonomous compute session. AI coding assistants serve as the ultimate stress test for this new economic reality. Software development presents the perfect conditions for a cost blowup. Repositories contain massive file context, the workflow requires constant iteration, and developers demand access to premium reasoning models. In June 2026, GitHub Copilot restructured its billing. They abandoned flat rates for heavy behaviors, moving to compute-based AI credits tied directly to input, output, and cache tokens. Cursor made a similar transition to compute-style usage limits, eventually introducing a $200 Ultra plan specifically to cover the unpredictable compute generated by power users. Anthropic's Claude Code enterprise metrics demonstrate the same curve. Reporting showed an average enterprise developer cost of $13 per active day. In one extreme case, a single user generated $35,000 of inference usage while paying for a $200 subscription. The era of unlimited, flat-rate AI subscriptions is over for professional-grade power users. The underlying compute is simply too large to hide. This massive compute demand requires an equally massive physical build-out. Market reporting projects that major tech giants could collectively invest roughly $650 billion in AI infrastructure in 2026 alone. At this scale, AI has outgrown its identity as a software business. It is now constrained by physical bottlenecks: raw energy generation, land acquisition, cooling systems, and data center capacity. This scarcity will hit users directly, appearing as friction, peak hour throttling, and priority queuing, rather than sudden, massive base price hikes. To survive this, we are entering a routing economy. Smart companies are actively redirecting generic, easy tasks away from frontier models and routing them to drastically cheaper open-source alternatives. Open-source models will not make your complex AI agents cheaper to run, but they are the only reliable way to shield your basic workloads from premium inference meters. Enterprise AI is moving past the experimental pilot phase. It is now a category defined by CFO-mandated budget governance. This chart compares the obsolete financial model with the new necessity. The left side relies on unit cost forecasting, projecting expenses based on flat subscription seats or basic token counts. The right side forecasts based on usage growth and defined agent boundaries. Base software budgets strictly on projected usage growth and capability expansion. Never forecast based on the deflating unit price of a single token. Architect enterprise software with hard, unbreachable operational ceilings on agent loops. Without these limits, autonomous retries result in catastrophic runaway inference costs. Finally, shift all internal product metrics away from cost per token. The only sustainable measurement is cost per completed outcome. Stop optimizing for the cost of a thought and start budgeting for the cost of the labor.